Hello, chemists. Welcome to week 4. We're going to be looking at ionic compounds. And really, that's a new word for us, ionic compounds. You've heard of ions before in our past week's investigations, but this is the first time we're doing ionic compounds. And the other term for that is just salts. And so I've got here's a bunch of salts. I've got 5 different salts. And you notice that some of them look like what you would think of as, salt or table salt. But the other ones kind of don't look like what you would think of as table salt. And that's because there's hundreds, if not thousands, of different salts. And that's because you can combine any metal with any non-metal and get a simple salt. So we're going to look at some simple salts this week and see what makes them the way that they are and what are the rules that govern their combining and how do they work. So that's what we're going to be looking at, salts or ionic compounds this week. To look at salts, we're going to be doing a lot of reviewing of what we've learned before. Here you'll notice that I'm in this, the periodictable.com, ptable.com, the properties series. I've got all of these links are in the instructions, but just show you what these are. We got properties and series, and you notice that we can see what all, they kind of have all the elements bunched by what kind of element they are. You notice that these are all, if you look here, right here, all of these guys are the alkali metals. These guys are the alkaline earth metals. You can see it change over here whenever I touch it. The transition metals, all of these red ones are the transition metals. And you can see it change over there when I do that. Then all these blue ones are the post-transition metals. And then we've got our metalloids here in teal. And then we've got in green the non-reactive, or sorry, no, they are very reactive. The reactive non-metals, and even hydrogen is over here in with the reactive non-metals as well. And then in purple, way over here all by themselves, the royal noble gases, and they're all over there. So we're going to be using this one to figure out whether something is a metal or a non-metal. Theoretically, we've already kind of figured that out, in our past, in the metal or non-metal investigation. So we should know that these guys are all metals and these guys are non-metals. And we're going to see when we combine these two, when we react a metal with a non-metal, usually it involves some flames and burning and some crazy reactions. I'll show some of those. We'll show those next week or 2 weeks. I'm not sure. Anyway, when we have those reactions, it's usually some fire involved. And so we've got metals and non-metals react to make salts. Okay, so let's look at what that looks like. You have this thing that you guys filled out before you put in the little valence electrons. And you notice that hydrogen has 1 and lithium has 1 valence electron, and sodium also has only 1 valence electron. Beryllium has 2. Magnesium has 2, and you notice this pattern of the valence electrons. This guy has a full valence shell, this one has a full valence shell, this one has a full valence shell. And what I said in the instructions is that full valence shells are way more stable than anytime there is not a full valence shell. So if you have an element that has it only has 7, like this fluorine here, if it only has 7 valence electrons, that means it's got space for 1 more. It just needs 1 more electron in order to be full and stable like neon. And so oxygen just needs 2 more electrons, and then lithium has this 1 dumb electron taking up an entire valence shell and making it really unstable. It would rather just not have that electron and be more stable. So anyway, so in order to become stable, they lose or gain electrons when they react. And you'll see that hopefully. So what I'd like you to do is, what you're going to do is you go to this periodic table here. Not this one, actually. We're going to go to the compounds one. So not the series where it says whether they're metals or non-metals. We're going to go to the compounds one. And do you see how if I go like this, if I take a, let's just do table salt. So if I take sodium and I drag it into this box, and that's going to tell me which other elements will sodium react with. It's got them all lit up here in colors. The ones that it will not react with are just gray, are all grayed out. So if sodium makes some sort of compound with an element, it is lit up. So I'm going to look for some non-metals. And remember, the non-metals are over here. We're going to look for a non-metal. And let's just do table salt because we know it exists. And I'm going to take the chlorine and I'm going to grab the chlorine and pull it over here. And now I'm going to see what compounds exist with sodium and chlorine. And right at the top will be the simplest one, hopefully, with any luck. And we've got sodium and chlorine make sodium chloride. And that is just table salt. And if I click on it, I'm going to go to the little Wikipedia page, and it's sodium chloride, commonly known as salt. And ionic, yeah, which is what we use on our food all the time. That's our blah, blah, blah. And you end up with the period, and then you can see, oh yeah, that does look like crystals of salt and all that. Yeah, we get the whole Wikipedia thing on sodium chloride when we click on the name of the salt. And I'm hoping that what we're doing this time is we're going to try to figure out what's up with these formulas and what's up with the names. How did they come up with the names of the salts, and what do these formulas mean? So that is how we do that. We drag them in there. Let's take, oh look, chlorine reacts with a lot of things. Let's do another one that I have as an example. Let's do magnesium. You notice a lot of elements went away. We have just these non-metals available over here. Let's take chlorine again and see what magnesium and chlorine make. Ah, there it is. Magnesium chloride, or MgCl2. We're going to see a lot of chlorine. So I noticed a lot of you were saying Ci. Well, that would be carbon and iodine. Ci would be carbon and iodine, but Cl, super common in all of these things. We're going to see a lot of chlorine. It's hard to tell if it's an I or an L, but just kind of assume that it's a Cl unless told otherwise. So magnesium chloride. There's our magnesium chloride, and if we click on it, we end up with the Wikipedia page. And then I'd like to point out, like, do you notice that it has one magnesium and two chlorines? And one of the things I would like you to try to figure out is why does sodium formula only have one sodium and one chlorine? And why does magnesium have one magnesium and two chlorines? Why does it look, and I'll show you the data table that I have here. Why does sodium have one ion react with one chlorine ion? And why does magnesium ion react with two chlorine ions? That's what I want you to try to figure out. So your job, first, a good place to start, you're going to, of course, look at the salts, but then you're going to try to fill in this data table. And I'm hoping as you fill in the data table, you'll start seeing those patterns, start figuring out patterns of the names, like how do they name these things and why do they have the formulas that they do? And does it have to do with valence electrons and charge? Probably, because I put them on there. So yeah, and then look at the Wikipedia page and see, like, what's it look like? Is it, you know, is it a liquid? Is it a solid or a gas? What color is it? Is it crystalline? Is it a metal? All those things. You're going to look at the properties of the salt over there. So you're filling, first thing to do is fill in the data table by looking at dragging those elements in and seeing what their formula is, and then also what their name is. Okay.